So let's cover z-scores. When we talked about z-scores in class, we used this example, and I want to cover it again because I feel like it actually does a very good job of explaining what a z-score is. And we've defined a z-score now as the number of standard deviations a value falls above or below a mean. So this is literally measuring standard deviations. This is the number of standard deviations above or below the mean. And remember, a value is a positive z-score if it's greater than the mean. And a value is a negative z-score if it is less than the mean. And the only way to have a z-score, though, is for our mean of our curve or our normal curve has to be 0. And our standard deviation has to be 1. And we call that a standard normal. That is called a standard normal curve. So if you ever refer to the standard normal, remember the word standard means average. So you're looking at the average, and the word normal actually means average in statistics too. So you're looking at the average curve here, or it's a curve that we can use for comparison. And here's why we need it. We look at this example where we talk about the SAT and the ACT, and we try to compare the scores like they are. Remember, you have two applicants, Jake and Angela, and then Jake scored a 1340. And the mean of his test score, the mean of the SAT, mu was equal to 1100. And that's up here in the problem, had a mean of 1100. And the standard deviation, sigma, was equal to 150. And then Angela scored on her particular test, Angela scored a 30, but her ACT, the mean was a 23, and the standard deviation here was 4. And we can tell that if Jake scored a 1340, if we compare that to the mean right here, Jake scored significantly higher than the mean. Well, how much higher did he score? We tried to do this in class, and I showed you in class, we drew a normal curve, and we labeled it with Jake's information on it. And so on Jake's curve, we know our mean is at 1100. And we spread the standard deviations out by 150. You get, first value would be 1250. Next standard deviation would be 1400. Remember, it's adding 150 to get there, and the last value would be 1550. Three standard deviations underneath this curve to the right of the mean. And we know that Jake scored then, when we look at Jake's score, if Jake scored a 1340 is about right here. It's not 2 full standard deviations, but it's pretty close to 2 full standard deviations away. Do the same thing for Angela's curve. And draw her curve and label it again. Her mean is at 23. And we have spread out by 4, so that's 27, 31, and 35. And when I look at this now, I see that Angela's ACT score, which was a 30, put her just shy of 2 full standard deviations as well. So the problem with this is now we know they both scored better than 1 full standard deviation and almost 2 standard deviations. So it's really hard to tell who did better because we have different means with different standard deviations. So what we can do is find their z-score and put them all back on the same curve right here. And to find the z-score, the variable z is equal to x minus the mean mu divided by the standard deviation. So for Jake, his z-score, I'll call it z of j, is equal to 1340 minus 1100 divided by his standard deviation, which is 150. And when I do that, I get 1.6. So Jake had a z-score of 1.6. And what it does now is it puts us on our normal curve, on our standard normal, actually. And so 1.6 is going to fall about right here. So here is Jake's z-score. For Angela, we do z is equal to, and I'll call it z of a. She scored a 30 minus her mean, which was 23, divided by her standard deviation, which was 4. Angela scored a 1.75 on hers. And so when we do 1.75, we see that she's here. So when we compare results relative to the mean, Who is higher relative to the mean? Well, you can tell now that Angela is higher. And because Angela is higher, she should actually get the scholarship. And let's talk about one more thing. What do these actual numbers mean? 1.6. Realize we're measuring now standard deviations. So this is 1.6 standard deviations above the mean. That's what Jake scored. Angela scored 1.75 standard deviations above the mean. So that's how we use a z-score for comparison of position.